We'll now discuss California Mechanical Code Chapters 12 and 13, which describe the requirements for hydronics and fuel gas piping, respectively. Chapter 12 of the California Mechanical Code deals specifically with hydronics. And hydronics are basically plumbing piping systems that are used to perform mechanical duties. These can include operation of parts of the HVAC system or other cooling and refrigeration systems, including the transmission of steam, hot water, chilled water, steam condensate, condenser water, and also geothermal or ground source heat pump systems. The piping that's used for hydronic systems, if it's within reach of occupants, which is generally understood to be within 7 feet above finished floor, must be insulated if it's conducting or transporting water or steam that is that exceeds 140 degrees Fahrenheit in temperature. Because of the interrelationship between the plumbing and the hydronic systems, or the plumbing and the mechanical systems, it's extremely important that all hydronic systems include some sort of backflow prevention that precludes any type of contamination of the potable water supply. So the potable water supply has certainly got to be protected from any hydronic systems. The identification of potable and non-potable water systems located in the California Mechanical Code are similar, if not identical, to those found in the California Plumbing Code, Section 601.3. And simply stated, potable and non-potable water are required to be identified, and the background color and the information is required to be sized in accordance with Table 1204.3. The potable and non-potable water systems are required to be identified every 20 feet on center minimum. Also as a further minimum, there is requirements for one identification label minimum per room. These identification labels are required to be visible from the floor. They are required to identify the type of liquid that is being conveyed, and also identify the direction of flow of the liquid. Section 1205 deals specifically with the installation, testing, and inspection of hydronic piping systems. First and foremost, the operations and maintenance manuals are required to be provided to the owner, and hydrostatic pressure testing is required at pressures 1.5 times the operating pressure, and additionally 100 psi minimum. These tests are required to have a 30-minute duration minimum, and no leaks are permitted in the piping systems. Air may be tested or may be used for testing in these hydronic piping systems, except for when plastic is used. However, there is an exception. It is new to the 2019 California Mechanical Code, and it's similar to the same exception that we have seen in the 2019 version of the California Plumbing Code, and that is that air may in fact be used for testing various plastic pipes, such as polyethylene, PEX, and polypropylene piping systems, where the actual manufacturer's installation instructions permit testing with air. Where the previous code cycles of the California Mechanical Code specifically stipulated that heating sources in their piping systems are required to be flushed after their installation with water or cleaning solution. In accordance with the manufacturer's installation instructions, the 2019 edition has also added that cooling piping systems must also be flushed in a similar manner to heating piping systems. And in addition to the inspection requirements for testing installed piping systems, it's also important to recognize that any supports for hydronic piping systems must also be inspected. And we've included this particular slide because it depicts a column that's actually got a cutout in it, providing access to the other end of a U-bolt that is holding a piece of hydronic piping to this stand or this support setup. Ordinarily on a project, if you saw a cutout like this in a structural member, it should probably stick out as a red flag. You might want to look at this similar to how you would see, say, surface-mounted conduit. It's an unusual thing in a new building, and you should look at it in an unusual way, and it should certainly be a red flag. In this particular instance, the project inspector did have concerns about this, and upon reviewing the actual plans for the project, it was verified that DSA did in fact review and approve this exact installation, including the cutout that was required for access to the other side of the U-bolt. But the point is, for this particular slide, always remain ever vigilant with the supporting structures for hydronic piping, and review those as well with the same diligence that you would with the piping system, and maintaining compatibility and separation of potable and non-potable water sources. Now we'll talk just briefly about Chapter 13 of the California Mechanical Code, which is fuel gas piping. Basically, this particular chapter reiterates all of the information that was already provided in the California Plumbing Code, Chapter 12. So we're not going to re-review it here, but it is important to say that one thing, since we are talking about the California Plumbing Code and the relationships between the California Mechanical Code, that there are certainly situations where there may be conflicts between the California Mechanical Code and the California Plumbing Code, and it's important to understand that both the California Mechanical Code and the California Plumbing Code, Section 1.1.7, discuss order of precedence and use. And to basically summarize, it's important to understand that building standards will always govern over standard references, and that specific provisions will govern over general provisions. And the biggie here when we're discussing these two separate trades and conflicts which may arise between them is that the most restrictive requirements govern when conflicts are realized between codes, whether the conflicts are realized between the CPC and CMC, or the CMC and the CBC, the California Building Code. It's important to realize this distinction, that the most restrictive requirement governs. Continuing with a couple of specific items in Chapter 13 that deal with fuel gas piping, Section 1303.0 generally discusses inspections. However, details for inspection of mechanical systems are included in Section 1314. And again, generally speaking, all excavations are required to be kept open until the piping has been inspected and approved. And the California Mechanical Code identifies two types of inspection, one being rough piping inspection, and this is the inspection that is performed after the piping is installed but prior to the piping being covered or concealed, or attachment of fixtures or appliances to the piping. It basically determines and verifies that the gas size, the material, and the installation itself meets the code requirements. The other type of piping inspection that's identified is called the final piping inspection. This particular inspection is performed after the piping is covered and concealed, but prior to any fixture, appliance, or shutoff valve installations. That concludes our Project Inspector Overview training session for the California Mechanical Code, the 2019 edition. And to quickly summarize the topics we covered, they were governing standards, references, applicable form DSA 152 items, Chapter 2, definitions, Chapter 3, general requirements, Chapter 4, ventilation air, Chapter 5, exhaust systems, Chapter 6, duct systems, Chapter 7, combustion air, Chapter 8, chimneys and vents, Chapter 9, installation of specific appliances, Chapter 10, steam and hot water boilers, Chapter 11, refrigeration, Chapter 12, hydronics, and finally Chapter 13, fuel gas piping. In closing, I'd like to thank everybody for their participation in this Project Inspector Overview training, specifically the 2019 version of the California Mechanical Code. My name is Jim Gibbons. I'm a Construction Supervisor 2 with the Division of the State Architect, and I'd like to close by leaving with a statement intended to assist all project inspectors in becoming a better project inspector. And I firmly believe that if you take these simple words to heart, that you'll become a better project inspector tomorrow. And this advice is this: read every word and symbol on every plan and specification sheet for every project, every time. That will help. Thank you again.